Still you got any doubt? Do you have any doubt in this? How it has to be done? So from this, we can summarize that like with the help of EDA tool, that is electron design automation tools, are available to automate the process and cut the design cycle time. Still, the designers can you can control how the tool will perform. Normally, so based on your circuit, the tool will perform very fastly, but it won't give you the more efficient result normally, because as a designers we need to perform manually. The automated process, it will be reduce your time burden actually. That is the only it will play a very important role nowadays. Next is the importance of HDL. How the HDL is very important over there. Now here in this you can say that designers can be described at a various abstract level, in the sense data flow, gate level, behavior model, or example is switch level also by using the HDL language. The second thing is we can say that designers can write their own RTL description. Always you think if I say RTL description means that is nothing but the behavioral description. Normally I can say the designers who is writing the coding, source coding. That only I can call as RTL description. So we can say that designers can write their own RTL description without choosing a specific fabrication technology. In the sense, no need to design or no need to choose the fabrication technology. As I said earlier, fabrication technology in the sense like you no need to worry for which technology you are writing the program. Technology in the sense, the meaning is the length of the channel. 90 nanometer, 45 nanometer. You no need to worry about that for which technology you are writing, because by writing the coding, that is not at all required. Next, here the logic synthesis tool. The logic synthesis tool will automatically convert the design to any fabrication technology. That is one of the very beautiful in EDA, the logic synthesis tool. Now, next we can say the logic synthesis tool will optimize the circuit in area and the timing for the new technology. So now by describing the designs in a HDL, the fabrication, that is nothing but the final verification, or I can say the functional verification. The functional verification of the design can be done early in the design cycle actually. Because if you want to verify your program, that is the functionality verification of the design can be done early in the design cycle. So like in the design cycle, we've seen some 3 levels of testing or verification levels we've seen. So since the designers will work at the RTL level, the designers in the sense B only, because normally in the VLSI if we take, we are having 2 different types of work is there. The one the work is, we can say front end design. Normally they will call front end design. The job roles, front end design and back end design. Front end design in the sense, I can say the front end design normally, which will be the front end the sense, I can say writing the code. That is what we can say front end design, writing the code and developing the architecture. This and all will be in the front end design. But back end design in the sense, what I can say back end design, so it is like draw a schematic, or I can say layout. This I can call as normally, you can say physical design. That is why if you see in any real estate companies, they'll call physical design engineers will be there. That is back-end design. So now here we can say, since the designers will be worked at the RTL level, they can optimize or they can modify the RTL description until it meets the desired functionality. So because once the specification is given, we know that what is the functionality we have to get. So the designers can do optimize and modify their own codes until they meet their desired functionality. So now some of the time what will happen, designing with the HDL is analogous to computer programming. So now here one more thing I can say, HDL design is here to stay, very, very important. The functional verification, earlier the design cycle we said, then the textual consists representation of the design. That is, it is similar to computer programs. That is why I said it is similar to computer programs in the sense what I said earlier, as I said. So like a computer program in the sense we can call this, it is a software programming. It is similar to that only. Next, very important, is easier to understand. That is very, very important here. The importance of HDL will be very, very easy to understand. So in this, these are the importance for HDL. Next is the what is the popularity of Verilog HDL? How it is very popular nowadays. So we can say how it is very popular in the sense. So the Verilog HDL is a general purpose hardware description language. It is easy to learn and easy to use. So it is very similar to syntax to the C programming language. This is what already as I said. Next, we can say the Verilog HDL will allow the different level of abstractions and we can mixing them also. In the sense, we can write individual level of abstraction. Level of abstraction in the sense, always you have to keep it in your mind. That is nothing but already we studied data flow modeling, gate level modeling, behavior modeling. Example. So on mixing them, even you can mix any two model or all the three model also they can mix this. Even though one more is I said as like what switch level description, even that also can be written. The switch level in the sense it is a very, very lowest abstract level of Verilog program that describes the transistors. From the transistor level, we can write the programming. Normally, that we won't use. Next, it will support by most popular logic synthesis tool. Most popular logic synthesis nowadays, as I said, most EDA tools and all I said. So it will be supported. Next, the post logic synthesis simulation libraries by all fabrication vendors. So very, very important the popularity here after the synthesis, that is post logic synthesis simulation libraries by all fabrication vendors. Who want all the fabrication vendors? Who is fabricating our IC? Next, very important thing in the Verilog, PLI. What is the PLI here in the sense? The PLI is nothing but the PLI is programming language interface. Programming language interface. So it is a powerful feature actually. So a powerful feature that allows the user to write custom C code to interact with the internal data structure of Verilog. This PLI actually. So the designers also IEEE standard defines the programming language interface, or we can call this PLI. So this is the collection of software subroutines which permits a bidirectional interface between Verilog and other languages. You can interface Verilog with the C languages, Verilog with the Java, Verilog with the OOPS-based concept. Whatever the languages are there, you can interface. This is what very, very important. That is why the Verilog HDL is so very popular. You can interface those two also. So designers can customize the Verilog HDL simulator to the needs with the PLI. So that is the popularity. What are the trends in HDL? Now, so here very important the trends in HDL is here. The speed and the complexity of digital circuits have increased rapidly. So next we can say the designers have responded by designing at a higher level of abstractions. Now the designers has to think only in terms of functionality. Normally, the designers has to think in terms of functionality only. The EDA tools will take care of the implementation details. So with the designer assistance, the EDA tool have become sophisticated enough to achieve a loose to optimum implementation. So sophisticated. So now we can say the very most the popular trend that currently is to design in HDL at a RTL level because of logic synthesis tool. So that will create a gate level netlist from the RTL level design. Next, we can say it has the very high speed and time critical circuits. So we can say example, the trends example microprocessor, we can mix the gate level under RTL designs, we can say. Next here, we can have like something called as the trends we are having new verification languages. If you want to perform any verification of the circuit, the new language has come, that is the verification language, also can be gained there. So these languages combine the parallelism and the hardware constructs from HDL with OOPS, that is object oriented programming such as C++. The nature of C++ we can say. So now we can say the one more thing is here, the hardware software co-design. That is what I said, the system level languages. The system level languages in the sense system C, Specman C. This is Spec C, something called as Spec C means Specman C. These are the some hardware co-designs. So these are the some trends in the HDLs normally. Then one more thing also we can say the HDL language also will provide or you can say support for automatic stimulus creation, checking and coverage. Something means code coverage they may call. However, these languages do not replace Verilog HDL. Next, we can say the formal verification and assertion checking techniques are emerging here. Next here in this we can say in our HDL the behavioral synthesis did not gain widespread acceptance because today the RTL design continues to be very popular. So due to that the Verilog HDL is also being constantly enhanced to meet the needs of new verification methodologies actually. So these are the some trends here. So it will practices the opposite to the high level design paradigm. So it's a frequently used for high speed designs normally because designers need to squeeze the last bit of time out of circuits. So normally what will happen when the designers are thinking to write any code, finally what will happen, they will reduce the time, they need to squeeze the time, then the last time for time out for the circuit and EDA tools sometimes prove to be insufficient to achieve the design result. Just like if you do any hurry, so you may think if you do the mistake, so automatically what will happen, EDA tool also will give you the wrong result only at the time due to what? Due to the insufficient actually. So insufficient you can't able to achieve the desired results. So you need to perform properly or I can say you need to be very careful while designing the circuits. In our subject, we are going to study the test bench program. The test bench program is going to test the program which you written already instead of using the or manually forcing the value through external program. I can give the inputs with the help of timing delays. So that is what we are going to do. That is what you can call the stimulus block. We can call this is stimulus block. This is nothing but your CUD block. So this will drive, this will generate the output. Again, you can check. This is the test bench. So later we are going to write the test bench program. Why? Because hereafter all the modules, when you are writing the main program, we must to write the test program also. So you need to know how to write the test bench program. That is very important. So even that also I will teach now itself. So it will be very easy for you how the test bench program will be useful. So at the same time, I'll show the demo also how the test benches can be used in the programs in the through software also. That also I will show. So this is all about today's class. So in the next class, we are going to deal with the test bench program. So don't forget, try to attend that. If you miss that test bench program, so you cannot write how the test bench program has to be written. Very, very important concept in the next class. So that's all about today's class. Thank you for everyone.